Hey guys, I just made a optimization toolbox with MATLAB software for 7 different optimization problems of beam packing problem, clustering, image quantization, image segmentation, parallel machine scheduling, regression, and TSP. So beam packing problem. As you can see, we have different files in installation file, which is mlapp install. You can install this in your application section here. For example, this one is this file, this app, or you can just run it as a mlapp and edit your software here or IDE here. Also, there are separated files for different algorithms. 4 different algorithms are selected, which are differential evolution, this one, for that specific problem, which is beam packing problem here, Firefly Algorithm, harmony search algorithm, and TLBO algorithm. Well, differential evolution is an optimization algorithm related to evolutionary algorithm category. Firefly is Swarm based optimization algorithm, harmony search is physique-based, and TLBO is human-based. So basically I used 4 of them. I use all of them. So for example, differential evolution, here you can see your items for bin packing problem and bin size. Then you can create bin packing model here by create model function, your cost function, which is bin packing cost. Then you can define your number of iteration and population here, and then it starts with a differential evolution algorithm and return the result at the end. So it is possible to be run. So we can see the performance of differential evolution on beam packing problem with here we can see with 35 items. It just selected 6 beams here, and we can see beams index here, items value here, and items index here, and that is runtime in second. What about the software? As you can see, it is possible to be done here too. You can run your software and define number of bin size, iterations, and population, size of bin size. You can load your CV, which we have a file here, and then you can run with TLBO, DE, HS, and FA algorithms. I use TLBO here. It's working with 200 iterations. We can see the performance of TLBO here, and item index and item values here. How many bins is used with this algorithm? 5, with bin size of 35 for each bin, and there are 25 items. It happened with 5 bins in around 2 seconds, 3 seconds. So what about DE with the same problem? Okay, it is 5 bins, a little bit faster. Harmony search is faster, but not as precise as DE and TLBO. Firefly is very slow. but very precise. You can see conversions happened in the beginning iterations. Well, there is app. Okay, you can run it as app here in packing problem. This is an app. You can make an exe file out of this with this file. This one. Okay. Same as that. For example, harmony search. Same happens here. Okay, we have the same for clustering here. We have mlapp file and mlapp install file. mlapp file. Here you can run it for clustering and load your file. Here we have iris dataset and run it with TLBO, for example. Here you can define number of segments or clusters, iterations and population, and also you can see your data. If you can define number of features. As we know, we have 40 features, for example 1 of 4. You can see data and you can use your algorithm, and you can see the result based on number of features. We have feature 1 and 2 and you can see this. Or 1 and 4, we can see this. Same as code file here. You can run it. Iteration, performance, and result. Also, you can run it as app. See the result. You can see runtime and cost value here. Okay, we have the same for image quantization, and you can run it here. Okay, after loading file, so here we have bubble file, bubble image. You can run it with your number of colors. It is image quantization. You want to reduce the image size for all devices. Iteration, population, and number of bins for image histogram. Load the image and TLBO, for example. We can see image histogram of the quantized image here and performance of the related algorithm, or DE, or harmony search, or Firefly. Firefly is a little bit heavier and more complex, but the result is much better. At the same time, you can get the statistical result of PSNR and SSIM. PSNR is 22, higher the better, to around 50. SSIM is better when it's close to 1, as we can see, it's 0.85. It's very good. What about DE? It's less because it's not as robust as Firefly. What about HS? It's around DE. What about TLBO? TLBO is very good. It's fast and precise. What about the increased number of population? For example, 30. It's getting slower but better. It doesn't change anything. Oh, it's so slow. Let's see if we can increase the SSIM value. It should increase the value Let's see what happens after 20 iterations. Yes, it increased it, but not so much. What about 10 population, but 100 iterations? It is good. How many search? It is good. TLBO. It's good. Okay, like other problems, you can run your M file as a separated file, like this, for example. See the result, or you can run it as app, as we have it here. And get the result. Also, I have to mention that all of these files and folders for optimization toolbox is in my GitHub profile, which I'm going to add this in the video description part. It is my GitHub. You can see readme file, all the folders and files, and even a preview to all applications. Also, same is on my MacBook profile, and you can find all the files here. So we have image segmentation problem here in my GitHub, and for running it, we have mlapp file. You can run it. So we can load the image and define number of segments, iteration, and population. As we want to compare it with ground truth data, we just use 2 segments. You can see runtime, cost value, and iteration number. So you can load ground truth data and push the button of statistics. You can see accuracy, precision, recall, F-score, Jaccard, DICE, and MSCC. Segmentation performance metrics, different algorithms, different results. So we have them as code file here. You can increase the number of segments, something like that appears, or you just can run image segmentation app, which you can install it by this file, installing this file. It just appears, you push the install, and it's over. So, for example, here you can increase it to 5 segments. You can see this is for 5. It is for this image we just need 4 because we have 4 colors. Anyways, here we have parallel motion scheduling. You can run it in mlapp file, you get this IDE. You can define number of iteration, population, and number of machines, task, process time minimum, process time maximum, setup time minimum, and setup time maximum. So we have minimum time for process time 10 and 24 the max, setup time mean 3 and 9, and TLBO. You can see completion time or Cmax is 86 for same problem by TLBO. The less the better, less time the better. For differential evolution, 87, harmony search 94, Firefly 75. Firefly is very good. So we're going to add number of machines to, for example, 9. What about this? Okay, each green square is a task, and here in y-axis we can see machines, and in x-axis we can see tasks. So as you can see, we had 9 machines, and here we have 9 machines and 20 tasks. Each green square contains a number, which each number represents a task here. And this space between squares are setup times. As we defined, it has a value between 3 and 9. And process time for each of these squares are between 10 and 20. But how many? 20 tasks. So what about if we have 7 machines but 30 tasks? This is for the differential evolution. As we can see, it wasn't needed for machine 7 to do something. What about harmony search? Okay, it assign to all of the machines 1, 2, 3, 4, 5, 6, 7. So you can see we have 30. As you can see, all of the we have 13 boxes which are tasks, and 7 rows, which means 7 machines, but completion time is 125. Now let's see who is better. TLBO 110. Okay, differential evolution 96, harmony search 125, and Firefly 94. That means Firefly is better. Again, you have it as separated file here. You can run it like this. It is working. But different algorithms for specific problem which you define, you can change the data and parameters. Finally, you will get completion time, runtime, and other data. Harmony search, and also you can run the application, related application, which is parallel machine scheduling. So same as that, as you can see. Okay, then we have regression. Here we can application part. We have an application part. In here, I'll just use TLBO and differential evolution algorithm as they return better results. You can load your CSV file here. Our data is this, which consisted of 15 samples. Each row represents a sample, and each column represents a feature. Final column is our target, which is a value between 1 and 3. So okay, You can define number of neurons for your neural network, iteration, population, and the learner. As you can see, definitions of them is here. I'm gonna use train loss. And you can see your features here. We have 10 features. For example, 2 and 5 scattered, and neurons is 9 is good. Iteration we are going for 100. Population 10. Okay, it is working. You can see the performance here. Okay, it will return a lot of things. Cost function, runtime. You can see MSE and R square and how it works between target and outputs, and errors. Now we have the same here, MSE, RMSE, R square, correlation coefficient, error mean, and error cd here. Now we can use differential evolution too. It is faster. See what happens. Okay. MSC or MSC. You can run them by regfile here as a code. You can define CSV file here, number of neurons, the learner, or you just can run the app in here. Okay, the last problem is traveling salesman problem, or TSP. Here we have coding part, for example DE TSP. We have X and Y here, which are our points. For instance, we can run its related application here, which you can install it by installing this file. So when you run the application, or you can use the code, doesn't matter. When you run the application, you have to load the CSV file. Here we have TSP, which this is X, this is Y, which is this. This is point 1, point 2, point 3, which is in position 91 for X and 37 for Y. You can see X and Y here. Number of population iteration you can define. Then you have to push these buttons, for example TLBO. So as you can see, this is the performance, cost, time, and but there is a problem here. You can run it again. It's still a problem. So here we can see the result, and you can use another algorithm. This is another path with different route, or harmony search, same as DE again, same as D, same as D, same as D. It's possible for an algorithm to have 2 or 3 answers for any problem. Firefly. So there's a code here, you can run it. Starts to solve the problem. by differential evolution algorithm. It couldn't. What about harmony search? What about harmony search? Yes. This problem is bigger and harder to solve. What about Firefly? As you can see, Firefly could solve the problem properly. And this is the final answer, final route. Again, as I mentioned earlier, you can find this toolbox in my Mathfork account here, or my GitHub account here. I'm gonna add these two addresses into the description of this video.